Hi, hi guys. Can you hear me now? Okay, cool. So what I was saying is that once the objects become very small, there is literally no information there, and if we try to get those objects, then other objects, the false positive goes up a lot. So we have seen that we were training a pedestrian detector, and when we tried to train it on very small objects, like they were barely visible, then fire hydrants, which look like cylinders, all cylindrical things, they started being classified as humans as well. So you have to be careful. At some level, there is not enough information to distinguish which one is which. Okay, let me check. Okay. So Mahendra, I have actually not tried Google or Facebook API for facial landmark detection. But other things that they offer, I don't even know whether they offer facial landmark detection. But iOS, for your project, iOS has a facial landmark detector, and that's really good now. It's in iOS 11. It's the same. Actually, it's the same performance as dlib, but your application size doesn't go up. And people who are looking at iOS, they should also look at the core module, core ML module in iOS. So they have a deep learning module in iOS now. You can actually train your own models elsewhere and port it very easily into iOS. And the performance also seems to be very good. We'll be doing a project on that. So we have done some background research and it looks very promising. So I have not physically tried it. I have seen demos of it. I suspect that it is actually going to be better than dlib. And the reason is that it is built internally and they don't have the overhead. They would have optimized it a lot because these APIs are going to be used by a lot of people. I don't know the memory usage, unfortunately. As far as I know, iOS 11 landmark detection is the same 68 points, but so what I have seen demos of it. I don't have hands-on experience on it yet, but what I have seen is people say that it is just as accurate as dlib. Nothing, I mean, nobody said that one is better than the other, but because it is part of the OS, the size, so when you try to include dlib's facial landmark detector, it is 100 megabytes. And even if you reduce the number of points, it is 30 megabytes. And I know people who have traded off, you can train it and trade off accuracy a little bit, and then it comes down to about a 15 megabyte. That is the best I have heard until now. Somebody who has a 68 point landmark detector and the size is very small. You can get there, but with iOS, that is almost free. The size of the app will not increase to hundreds of megabytes, maybe tens of megabytes, or not even that. Maybe it is part of the OS, and in that case, it's almost free. But I'll actually do some research, some more research on how this facial landmark detection on iOS 11, and in my next live session, we can have a small discussion around it. Has anybody else? I know Saideep mentioned that he has used. I know Mahendra has used some of the things that he has learned from the blog in a real world application. Has anybody used immediately, like whatever you have learned in this course? Have you been able to use it in a real world application? So I know at least 2-3 people who have used it immediately. But are there other people? Thanks, Mahendra. Yes, that's true. If you want fewer landmarks, then there are other solutions available there. Even older versions of iOS, I think they did give you a few points on the face. And just to inform you about, some current stuff that you might be interested in, people who are interested in Raspberry Pi and cannot get very high performance on Raspberry Pi for their deep learning projects, then they have the option of using this new stick called Movidius. Movidius allows you, it's a USB stick, and it allows you to do deep learning on the stick. So you can have an embedded device and just put this stick in it, do a lot of computation on the stick. I have ordered it, so it will be arriving soon. So I'm very excited about it. If I see good results, I'll write blog posts about it as well. So the name is Movidius. Yeah, it's I'm very excited about it. I have not tested it yet. It's in the mail. So once it arrives, I will have some hands-on experience, and then I'll be able to speak about it better. Any more questions? Yeah, there are a lot of interesting things happening in this deep learning for embedded devices. There is this company called XNOR.ai. They are also doing deep learning on the CPU as well as on very small devices. They are also, I mean, if you're interested in doing deep learning on very small embedded devices, you should check them out as well. XNOR.ai. So for glasses filter, I mean, there is a trivial way of doing it. You have to use head pose, and then you need to. So there are two parts to it. First of all, you need to find the assets. So you need to find, a single glass is not going to work because it's not 3D. For glasses, you need to be able to move the head. Now, for that, you need to collect data for the glass, which is, which has various tilts. And then based on the face, you actually have to put on the right glass from that collected data. So you will need head pose estimation in addition to, and you will also need a lot of some segmentation in addition to just just head pose estimation and putting the filter on, because as the head moves to the side, you need this sidebar, the temple of the glass as well. And there are companies dedicated to doing this. It's not an easy problem at all. Even on our company website, we have, like on Taz, my previous company, we did glasses. We did it for images, not for videos. And the data collection challenge is huge. And the final delivery in real time is also huge. So it's not an easy thing. It's not like a filter that you can do easily. To do it realistically, it is months of effort before you can get to a realistic result. But the way you would do it is you would do data collection. You would collect the data of eyeglass in various angles, and then you will work with the transparency of the glass. You need a rendering algorithm to render the lens, because if you just put lens on top of the face, it's going to look very plastic-like. So you need something that looks realistic, like a lens, especially with sunglasses. And then you need head pose estimation to figure out which glass that you have acquired will go on the face. And finally, you need some segmentation to figure out, how the glasses, when you turn your head, it occludes part of the face. So this temple is not visible when you're turning to the side. And this temple is visible, and this thing goes right behind the ears. So there is a lot of stuff that goes into just putting glasses on the face, if you want to do it realistically. If you don't want to do it realistically, then you can easily create a model, and then but you still need head pose estimation. You just need to, you can create a very trivial 3D model and pick the right image to display based on the size, based on the pose of the head. So that if you want to do something trivial, that's easy. It's not going to look realistic, but it would be funny. So Bang, I didn't understand the question about what do you want to implement on Android or iOS? So Google Tango is it's for so it's a whole system. It uses not an iPad, but a Google tablet, and the tablet needs to have a particular device. It's not available for all things, so they have this device that goes on the tablet, and they do depth map. So they give you a point cloud or a depth map. So it's, and the target audience for them is they are doing internal inside the house, they are trying to figure out spaces. Um, for face kind of application, I don't know how good it would be, because in all these applications, you need to make certain assumptions for it to work. And their assumption is that it is for VR applications where you're trying to figure out the space around you. It's almost like a room kind of setting where you're trying to figure out the 3D structure of the room as you go. For face kind of applications, that would be tougher. But as with a lot of Google things, Tango is still very, very early stage. It's not under wide scale adoption. So be careful if you want to build product on top of it. Be careful with that, because it's not ready for prime time yet. Oh, the warp, yeah. So the warp image function for Android and iOS, usually for all these, they would have even easier ways of doing it. Because in OpenGL, you would have a warp triangle directly. You don't have to write anything. The warp triangle function is already there, and you just apply it to the whole image. So it's very, very easy. Sometimes I cannot remember, I have not coded in OpenGL for a very long time, but sometimes you may be able to give a texture map and the underlying mesh, and it will do the warping. So it's usually, a couple of lines of code to do that kind of transformation in OpenGL. OpenCV is not a graphics library, so they have not optimized for triangles, but OpenGL, everything is a triangle. So texture mapping is very easy. Yes, I just mentioned xnor.ai. You should check it out. So on a Mac, it is actually easy. It's not tough at all. On a Mac, I know for sure, like you can, because they have two different packages. One is called OpenCV and the other is called OpenCV3. So on a Mac, I simply do brew install OpenCV and brew install OpenCV3. And then if I use, on Ubuntu, I'm not 100% sure. You can always use two different, maybe using virtual environments would be an option. WebHub maybe. So let me take this question and get back to you. We have done some experiments and we will be able to tell you how to do it. So Saideep, let me take this as a homework. I'll get back to you on what is the right way to do it. Maybe using virtual environments would work, but I need to confirm it with WebHub. Yeah. That's what I think, but I have not tried it myself. Okay. Yeah, looks like virtual environment is the way to go. That's interesting. Yeah, that's why I was being careful. Okay, let me take this as a homework and we will actually get back to you. Yeah, by after this release, we'll do some research to figure out what needs to be done. Well, none of them would give you a distance estimate because so this is the question from Mohammed is which of the two libraries, OpenCV or DLib, gives you more accurate distance estimate from the camera in case of video surveillance? So basically for distance estimate, you need to have calibration, and it does not matter. Like OpenCV would be the right tool to use in that case because OpenCV has a lot more functions available to do whatever, but you need a very calibrated setup. A single camera, finding a distance using a single camera is it's certainly possible if the camera is static and you're looking at a particular thing and you have a calibrated thing, you have a calibrated setup, you have some reference object in the scene, only then it is possible. But if you don't have a reference object, then finding distances is extremely tough. Yes, so stereo camera setups will work, but again, there are limitations, right? You have to have a stereo camera, you have to calibrate it very well, and if this thing needs to be, you need to have a stereo camera kind of setup. You know, you have to have a real stereo setup where this thing is, the two cameras are rigidly together. And even then there is a depth for surveillance camera. It becomes very difficult because there is a depth, there's only so much depth you can get accurately. If you're doing it in a very controlled environment, for example, inside a shopping mall or something, where things are very controlled and the spaces are smaller. If you're doing it in smaller spaces, then it becomes easier. But as the space gets larger, you need to have the way stereo works is you need to have disparity between the same object needs to be at two different locations in the two images, and that distance will tell you how far things are, right? So that disparity is the key. But as if you try to install these kinds of things in very in arbitrary settings, then they usually will not work very well, because first of all, to find depth, you need to be able to match points. So stereo cameras, they match points in one image to points in the other image. If things are smooth, there's sunlight, like in surveillance cameras, you can expect, you know, there will be huge sunlight affecting things, and things will not look similar in the two cameras. That's one thing. And then the resolution of the camera will limit how much depth you can see. So so there are challenges. It's not straightforward just taking two cameras and making them work in arbitrary settings. That's why most of the stereo setups you have, they are for very specific applications, like the Kinect camera that they have. It's a time of flight sensor, so it's different, but it is for a very specific thing that they are doing it for a specific amount of distance. They say that they can handle maybe, you know, 2 feet to, I don't know, 10 feet or something like that. So when you have those kinds of constraints, then you can say that, okay, I'm going to measure the depth, and the depth would have such granularity, right? But if it is completely arbitrary, like in surveillance cameras, you do not have a very good idea how far, where it would be mounted and how far things could be. So there are limitations like that. You have to be very careful about those situations. Okay, so do you guys have any other questions? Let's see. We have a few more minutes, so if you have questions, shoot away. So the final project you have to decide. I'm going to send an email this week. So you will decide what the final project would be. It would not be the same project for everybody. So the reason is that we want to, if we give the project, then it limits creativity, right? We don't see a variety. So the way it will work is you propose what project you're going to do and come up with some idea. And if it is a very difficult idea, we will tell you that, you won't be able to do it in 1 week, one month. So, so in that case, that would not be a good project idea. So what we will do is you will send us a project proposal and we will look at the proposal and approve it. Once the project is approved, you can go ahead and implement it. This way we will get a variety of many different ideas, many different applications. So it would be nice to see, different applications. We do not want all the people doing the same project. That's not a lot of fun. Yeah, so the reason Kinect 2 is better, Kinect 1 had, it was a projector camera system. It projected a pattern of light, and there was a projector and then there was a camera which looked at the pattern of the light and they did the triangulation. And because that pattern of light was based on infrared, it was, it won't work under direct sunlight. On the other hand, Kinect 2 is a time of flight sensor. It does better. Do I have any experience? I have not done handwritten signature recognition. I recently found a data set where there are a lot of signatures, but I have not done signature recognition personally. So Amar, we will send you an email. Earlier, the due date for proposal was August 15. Because we took a week off, we will just move that deadline by 1 week. So it would be something like August 21st. But watch out for an email. I'll send an email with all the details. Haha. So how do I smoothly collaborate with team in different geographic location? So I actually don't like so everything has to be managed using a very scheduled time window. So we actually meet every day at 8 a.m. my time. We meet every day for fixed amount of time, not fixed amount of time, whatever needs to be discussed. So for this course, we meet every day, and the meeting can be anywhere between 15 minutes to 45 minutes, or sometimes even an hour, depending on how much stuff we need to cover. So that way and then we use Asana for project management. We put the tasks for everybody on Asana, and there are deadlines we set for ourselves. And that way there is communication, one-time communication, and that's it, right? So people don't usually need to ask throughout the day what they need to do, because every day we report what we did last day and what we are going to do next. So this way it streamlines the entire thing. We know this is what we need to do, and the time is also good enough. It's not too late in India. It's 8:30 p.m. in India, and it's a reasonable time for me as well. So that way, having a daily stand-up meeting, that streamlines everything. Even if you're not having a daily stand-up meeting, it is much better to have scheduled meetings instead of ad hoc meetings. For a client, I used to have these ad hoc meetings. They would call me anytime they wanted, and that was ruining my. I could not plan out my day. It's very important that during the day you get 3-4 hour chunks of work which you can focus on, so that there is no distraction. You can just focus on that, on your work in those 3-4 hour chunks. And if you get distracted during that time, the productivity just goes down a lot. For that, it's very important to schedule all the meetings. For this client, what we did was we have meetings every 2 times a week, and it is scheduled. It is Tuesdays and Fridays we have these meetings. So now he doesn't call me at arbitrary times with arbitrary requests, because 2 times a week is enough to handle any kind of emergency. So schedule all the work that you want to do and keep undistracted, 3-4 hour chunks for yourself, so that you're not distracted. And you want to go do social media, you can do it, but outside that time, right? Fix that time for complete focused work. That's very important. Yeah, and there's this book called Deep Work, which I'm greatly influenced by. It's really nice to focus for a period of time without distraction. The productivity just shoots out of the roof. Oh, my email address is the email address I email from, spmalik@learnopencv.com. If you reply to it, I will reply. Unless, sometimes it goes in spam and things like that. But most of the time, if you email to that email address, I get it. Let me write it down. Yep. Okay, so that's it for today. That's it. And all the best, the people who are doing the prize assignment, all the best. No, it should not be unique. The project doesn't need to be unique, but the more interesting it is, your chances of winning become more. So it's a combination of how well the implementation is. So for example, even if you do say facial landmark detection or something, and you can show that the performance is very good, and you just used it's say you could say that, oh, it's really fast, or the model size is very small, even though then it becomes a very interesting thing. It doesn't need to be unique, because a lot of people have done facial landmark detection, but you have improved it in a non-trivial way. Apps, if you want to do any kinds of new applications, then it's a lower barrier to. It depends on your creativity. Once you have the right idea, maybe implementing the app is not that difficult, but because you had that right idea, it looks very interesting. So that's also perfectly fine. So you could take something that has been done by a lot of people, but you have improved it substantially, then that's good. Or you could do something that nobody has done. It doesn't take a lot of effort to do it, but the whole emphasis is on the idea that nobody had thought about it before. It's not, once you tell the idea, anybody can implement it, but your creativity lies in coming up with that one idea. In that category, I like to give this example of wheels on suitcases. So suitcases have been around for 2,000 years. Wheels have been around for 3,000 years, and still suitcases on wheels were invented in 1970. That was 1 year after man landed on moon, right? So that's the idea of a powerful idea. So it's a very simple idea. Once you tell somebody suitcases with wheels, anybody can implement it. But the idea was very interesting. Nobody had thought about it for so many years, that you can just put wheels on suitcases. And the patent was granted in 1970. So there, the idea was crucial. Okay, folks. So that's that. All the best for the remainder of the course, and all the best for the prize assignments. And of course, we'll send out an email about the final project also. And that's it for today. Thank you so much for joining. Thanks, Mark. Thank you, George. Thanks, Leo. Bye. Okay, guys. Bye. We'll see you next time.